S. Chand presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
In this part of the video, we'll cover linear programming problem aspects in which the constraint equations are mixed type. That means we are dealing with the more than type inequality and less than type inequality in a particular equation. And the method that we have to solve that particular set of equations is two-phase method. So we would be covering that two-phase method in this part of the video.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. We are doing the course Business Mathematics. The topic is linear programming problems, part of Business Mathematics course, and we will be covering two-phase method here. So what is the problem? The problem is related to maximization. That means you have an objective function here, and that objective function says that you have z equals to 3x1 minus x2, which is subjected to these particular constraints. And the constraints are 2x1 plus x2 that is greater than equal to 2, x1 plus 3x2 is less than equal to 2, and x2 is less than equal to 4. So first and foremost, you have to understand that you have to convert the set of constraint equations into set of equalities. So how can I do that? If you have a less than equal to type constraint, you have to add a slack variable to it. If you have more than equal to type constraint, you have to subtract the surplus variable and add an artificial variable to it. If it is having equality, then again also you have to add an artificial variable to it. So what is a slack variable? What is a surplus variable? We have already covered the same concept in our previous videos. If you haven't watched that video, you can visit the playlist of this channel for the business mathematics course, and you can watch those videos. Okay, so herein we have to convert the set of equations into standard form. So how can I do that? I have to write this equation as 2x1 plus x2. If it is more than equal to type, I need to subtract a surplus variable and add an artificial variable to it. It becomes 2. And then for the next case, what I need to do, I need to add a slack variable into it. So it is x1 plus 3x2. So I need to add a slack variable to it and put it equals to 2. Then you have another set which is x2 is less than equal to 4. So what we will do, we will be adding a slack variable to it, which is, let's say, s3, and that would be equal to 4. So we have got the addition of 3 different variables, and additionally we have got this artificial variable 1 into the picture. And the objective function needs to be changed also for the different slack and surplus variables. We have to write here 0s1, 0s2 and 0s3, and additionally we have to mention minus a here, because minus a1, because we have one artificial variable associated. So we need to write here minus a1 into the general objective function. Now the thing is, we have to go with the method, and the name of the method is two-phase method. That indicates that we have to perform this solution in 2 phases. So what would be the first phase? So in the first phase, what you will consider, in the first phase you will consider as all the decision variables as 0, x1 as 0 and x2 as 0. So all these decision variables would be 0. That means you would be writing here maximization of z, that would be equal to, all these decision variables are no doubt 0. So you will be only left with minus a1, and these constrained equations would remain the same. So it would be subjected to the similar constrained equation. So subjected to the constrained equations which would be same, that is 2x1 plus x2 minus s1 plus a1, that would be equal to 2. Then you have another equation which is x1 plus 3x2, x1 plus 3x2 plus s2, that is again equal to 2. And you have x2 plus s3 equals to 4. x2 plus s3 equals to 4. Now what is required in the first phase, you have done this, and our idea of incorporating the first phase like this is to convert this particular set into the simplex form. That means in the simplex method we had only those less than type constraints. If you haven't watched the video related to the simplex method, you can watch that video in the channel against the playlist of business mathematics. So what we have done in that particular situation, we don't have any more than type constraints. So here, as we have a more than type constraint, so we will try to remove that artificial variable initially and put in all the decision variables in that matrix. And ultimately we will be converting this table, which is related to two-phase problem, into a simplex method. So in order to solve it, I need to make a table, and that particular table would be related to certain set, which is CB basis solution. Above solution I have to mention CJ values, and I have to mention all these decision variables, which is x2, x1, x2, s1, s2, s3, and the artificial variable, which is 1. Okay, so we have to use this format in order to make the table, and I have written x1, x2, s1, s2, s3 and a1 as per the general requirement which was there in the objective function. So all these numbers are there in the objective function. Now I have to write the coefficient of the objective function, which is generally taken as 0 in the first phase, and here I have taken -1 because in the first phase I have chosen this z as -a1. So in terms of the objective function Cj, I have to write -1. Now the bases are there. So in terms of the bases, what I need to write, in the first case I have to choose from surplus and artificial. So from surplus and artificial I have to choose this artificial variable, which is a1. So I have to write a1. Then in the next case I have to choose this s2 because this is only variable associated. In the third I have to choose s3. So I have to write this as s2 and here as s3. So I have written these terms like this. Now what happens, I need to write the elements of CB. So in order to write those elements of CB, I have to look for the objective function case. So in terms of A1, I have the value which is -1. For S2, I have the value 0, and for S3, I have this value 0. For the solutions, what we have to write the coefficient of all these elements in the matrix, and for the solution, I have to write these right hand side terms. So we have 2, 2 and 4. So I have to use these numbers and mention here 2, 2 and 4. And for all these variables, I need to take the help of these constraint equations that I have converted into an equality. So 2, 1, -1 and a1. So I have here 2. Then for x2, I have 1. Then I have this -1 because S1's coefficient is -1. You don't have S2 and S3's coefficient, but you have the coefficient of artificial variable which is 1 here, so you need to write here 1. Then for the next set of equation, but we have 1, 3 and S2. So you have to write 1, 3, 0, 1, 0, 0. And for the third equation, what do you have? You have x2 and s3. So you have to write 0, 1, 0, 0, 1 and 0. Now you have to put a line and you have to write here Zj. So what is Zj? Zj is a sum product of CB elements and the elements of this X. So you need to use the product of the two, minus 1 into 2 plus 0 into 1 plus 0 into 0. So you have this minus 2 here. Then minus 1 into 1 plus 0 into 3 plus 0 into 0. So you'll have minus 1 here again. So in the next set, you have minus 1 into minus 1, which is plus 1, because all the other elements are 0, so I am not adding those zeros here. The next is 0 into 0, which is 0. Then for the next, it is again 0. For the A1 part, you have minus 1. Now, you need to find out what is Cj minus Zj. So, Cj minus Zj is 0 minus of minus 2. That means plus 2. Then you have 0 minus of minus 1, which is plus 1. 0 minus 1 is minus 1. Then there is 0. Then again a 0. Then minus 1 is again 0. So you got one particular matrix complete. And in that you have to look for the maximum of all the elements of Cj minus Zj. So the maximum of all the elements of Cj minus Zj is here, which is called as the key column. And I need to highlight this key column. So this key column is representing that x1 will be entering here somewhere here on the basis, but I don't know where should I put this x1 value. So for that I need to find out a theta minimum value. So theta minimum can be calculated by dividing the solution and the key column element. So 2 divided by 2, it would be 1. 2 divided by 1 is 2 and 4 divided by 1 is infinity, so I need to keep it blank. Now, as the name suggests, theta minimum, so I need to choose the minimum of the two numbers there. So the minimum is 1 here, so key row would be associated with 1. So herein the key row is this entire row, so I need to highlight this key row. And what I need to check for, I need to look for the element which is there in the basis. So element which is there in the basis is A1. So it indicates that A1 would be the leaving variable and X1 will be the entering variable. So in my next set of iteration, I will be putting A1 as X1 and the other elements will remain same. S2 and S3 will remain the same. And I'll be using the elements of the previous table for a particular solution. The rule says that the pivot element or the key element should be 1. So the intersection of the key column and the key row will give me this pivot element or key element. So I need to divide the entire row by 2 so that I may get 1. So divide this entire row by 2 so that I get 1. So that means 2 divided by 2 would be 1. 2 divided by 2 it would be 1. 1 divided by 2 is 1 by 2. Minus 1 divided by 2 is minus 1 by 2. 0 divided by 2 is 0. Then S3 divided 0 divided by 2 is 0. And as A1 is removed from here, so you need to remove the A1 part from here also. Now, what is the rule? The rule says that you need to make the other elements which are associated with the key elements as 0. So this row's element is already 0. That means we have to do nothing and we need to write the elements of this third row as it is. And for the next, you have to apply a row operation. What is that row operation? you can see that you have 1 and you have got this 1 again. So you need to subtract both of them so that your this element becomes 0. So how can I do that? I need to apply a row operation. So I'm writing that row operation here. The row operation would be R2 changes to R2 minus R1. This is my row operation. R2 changes to R2 minus R1. And which R2 and which R1 is this? So it has R2 which is new and this R2 is old. And here I have the new R1. New R1 means this is the R1 of the new element, new table, and above the R2 is the R2 for the old one. So I have to write all these elements vertically so as to avoid any set of calculation error. So I need to write all these elements in maybe in a rough column. So 2, 1, 3, then 0, then 1, and you have 0. So I have written these elements 2, 1, 3, 0, 1 and 0, 2, 1, 3, 0, 1 and 0, minus all these elements of the first row, which is 2 minus 1, which is 2 minus 1. Then you have 1 minus 1, then 3 minus 1 by 2, 3 minus of minus 1 by 2. Then you have 1 minus of minus 1 by 2. So I have to write 1, 1, 1 by 2 and minus 1 by 2. This is 0. This element is 0 and the next element is again 0. So this is 1, 1, 1 by 2, minus 1 by 2, 0 and 0. So 2 minus 1 is 1, 1 minus 1 is 0, 3 minus 1 by 2 is 5 by 2. This would be plus 1 by 2, this is 1 and this would be 0. So I need to write all the elements here, which is 0, sorry, the element would be, the first element would be 1, the next element is 0, then you have 5 by 2, then you have 1 by 2, then you have 1 and again a 0. So just to avoid any set of confusion or any set of calculation error, I have used this particular vertical method for writing those elements here. After this you have to go with Zj. So for Zj calculation you need the coefficient of these numbers. So as you can see in the table you have these 0, 0, 0 elements available. So here again I need to put in the elements as 0, 0 and 0. So why these elements are 0? Because as per the objective function. So from the objective function I have to put these elements as 0. Now after substituting the elements as 0 I need to find out Zj. So Zj is 0 into you can say 1, 0 into 0 and 0 into 0 again. So all these elements are 0, so you need to multiply them together and add them up. So it would be 0, then again element 0, then 0, then 0, then again a 0. Then you got Cj minus Zj, which is 0 minus 0, which is 0. All these elements would be 0 in this particular set. Now when this is 0, this first phase part is complete. In the next phase, what you will do, you will try to correlate that simplex problem with this particular solution that you have derived so far. So we stop here for a short break, and after coming back from the break, we will learn the aspect of the second phase of the two-phase method.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. Before going to the break, we have learned the concept of the first phase in a two-phase method. In the first phase, what we have done, we have taken all the decision variables as 0 and we tried to convert it into the simplex method. That means we have eliminated all those artificial variables and we are only left with slack or surplus variables. So we are only left with maybe a slack variable, and that slack variable would specifically deal with the simplex problem. So let us come to that problem that we were doing. So what we have done so far, we have written the same aspect of the two-phase method, and in the first phase what we have taken these elements as 0. So we have taken all these elements as 0 and we have applied that general steps, and in those general steps what we have got that Cj minus Zj values to be 0. Now in the next step, which is the second phase of this two-phase method, we have to make the table again. That means the table which we have made in general was CB basis solution, then you had x1, x2, s1, s2 and s3. You remember that artificial variable was eliminated, and we have to do what? We just have to copy the elements from here, right, from here to the last. That means this entire table from the first phase is to be copied to the second phase. That means all these elements would have to be written again. That means in basis x1, then s2, then s3. The CB part need not to be written as far as this step is concerned. For solution, we need to mention all these elements like 1, 1 and 4. So I am writing all these elements as 1, 1 and 4. For the next set of elements, we have this 1, 0, 0. I have to write here 1, 0, 0. Then you have the elements 1 by 2, 5 by 2 and 1. So 1 by 2, 5 by 2 and 1. Then the next elements are minus 1 by 2, 1 by 2 and 0. This is minus 1 by 2, 1 by 2 and 0. And the other elements are 0, 1, 0, 0, 1, 0, and it was 0, 0 and 1. And here you know that you have to make a column for Zj and Cj also. So in the first phase, you have got all these elements of Cj minus Zj as zeros. Now what is to be done in the second phase? In the second phase, you would come to the original question, and in the original question you would write all the coefficients of these variables. Like you had got 3, you have got minus 1 and 0, 0, 0. So all these elements are to be mentioned as it is in the second phase now. So you have to write Cj here and you have to write Zj here. In place of Cj, you have to mention the coefficient which is 3 and minus 1. So you have to mention the coefficients as 3 and minus 1, and rest of the elements will remain same, which is 0, 0, 0. And looking at this particular aspect in which you have written the original matrix, you have to write the coefficient of x1 as 3, coefficient of s2 as 0 and s3 again as 0. Now what you have done here, kindly look at the question carefully. Initially you have got a matrix which was connected to an artificial variable, and what we have done, we have removed that artificial variable and we are only left with these slack or surplus variables. Here also you can see that you are having this slack variable, here slack variable and here a decision variable. That means in the second phase the table is being converted into a same table that you have seen in case of a simplex method. If you haven't watched the video related to simplex method, you can visit the playlist of the channel, which is Business Mathematics, course and watch that video related to simplex method. So what you have done here, you have converted that less than or more than type constraint equation into one single set. And now our procedure would remain same. That means we need to follow the same steps of finding out Zj part, which is the Zj is the sum product of these two columns, which is X elements and CB elements. So we'll have to use this 3. So 3 into 1 plus 0 into 0 plus 0 into 0. So we'll write here 3. Then 3 into 1 by 2, which is 3 by 2, and plus 0 and zeros would remain the same. Then for the next part, you have 3 into minus half, so it would become minus 3 by 2. And for the next set of situation, you have 3 into 0 plus 0 into 0 plus 0 into 0, which is again a 0. Then 3 into 0 plus 0 into 0 plus 0 into 0 into 1, that would be 0. Then you have to find out Cj minus Zj. Cj minus Zj would be 3 minus 3, that is 0, and minus 1 by 2 minus 3 by 2. So that would be a negative number. So minus 5 by 2 would be the case. In the next, you have 0 plus 3 by 2. That means you got 3 by 2 here. And then 0 minus 0, then 0. So you have calculated this Cj minus Zj aspect. Now what is to be checked in this Cj minus Zj, and why are we finding out this Cj minus Zj? Cj minus Zj is basically a preliminary check that would tell us that the entire equation or the entire solution is optimized or not. Now if we look at our solution, this would be our solution. And if we want to check that whether this solution is an optimal solution, Cj minus Zj is that trial check. If all the elements of the Cj minus Zj are coming to be 0 and negatives, that means the objective function is optimized or our target is achieved. Otherwise, if it is not coming as negatives or zeros, then we have to repeat our iterations again. So here you can see that this 3 by 2 is positive, so you have to do your iterations again. But this 3 by 2 is indicative of the fact that this would be the key column, and it indicates that S1 would be entering somewhere here in the basis, and where it would be entering, that would be found by this theta minimum term. So theta minimum term would be found from the theta minimum term, and theta minimum term would be the division of the solution and the key columns element. So 1 divided by minus 1 by 2 will give me negative number, so I have to leave it. 1 divided by 1 by 2, that would be 2, and 4 divided by 0 would be negative, so I have to leave it. The only thing left is this one, so key row would be this row. That means I need to highlight this particular row, and it indicates that this row is the key row. That means this element is a key element, and S2 is that variable that is required to be removed from the particular basis. So what I'll do, in place of this x1, I'll keep it as it is. In place of S2, I need to write what? S1. So in place of S2, I need to mention S1, and S3 will remain the same. Now we'll go as per the rule. The rule says that this element should be 1. So in order to make this element as 1, I need to multiply the entire row by 2, so that it becomes 1. So the second row will become 2, 0, 5. This becomes 2, this becomes 2, and this becomes 0. Herein, there is one point to note that S1 entered this basis, but need not to remove that slack or surplus variable from this entire matrix. That is only done in case of an artificial variable. So this is written like this, and S3 already has a 0. So if it has a 0, you need not to do anything. You just need to write the entire set of elements as it is. So it would be 4, 1, 0, 0, and 1. And for the first one, you have minus half, and you have got this value which is 1. So what you got? 2 0, 5 and this would be 1, sorry. So this element would be 1. The next element will be 2 and this is 0. So herein you got the row 1 that needs to be transformed. So you need to apply a row operation which is R1 new, and that R1 new would be equal to R1 old, which is minus half added to half times R2 new. Half times means half times indicates that half times new indicates that minus half is already there, and if I multiply it with this 1 with half, so I'll get the same element. So in order to avoid any calculation error, I have written this, and vertically I'll write all these elements. So R1 old's element is to be written, so I need to write all the elements of R1. So I have got 1, I have got this 1 again, then 1 by 2, then I have got this number which is minus 1 by 2, then 0 and 0 are the two different numbers. Then I have got the plus sign, then half remains same, right, and write all the elements of the key row. So key row here is row number 2, so I have to write all the elements of the key row, which is the R2 value, but with a new element. So new key row, which is the second row's elements. So I have to write here 2, then this would be 0, and the next would be 5, then the next is 1, then 2, and then a 0. So 2 and 2 gets cancelled out, you will get a value 2. For this you will get 1. For this 5 by 2 plus 1 by 2 is 6 by 2, so that you will get a 3. Then 1 by 2 minus 1 by 2 plus 1 by 2, that would be 0. So 1 by 2 into 2 is 1, and here you will get a 0. So you got all the elements of the first row. Just copy all these elements and paste it here in the table. So what you will get this value as 2, then you will get 1, then 3, then 0, then 1, and then again a 0. So you got all these elements, and this part is to be taken as a separate aspect, and it need not to be mentioned separately in the question, or there is no requirement to show that particular step. So for that, what we will do, we will just try to calculate now Cj minus Zj and Zj values. So we will calculate the Zj, but before calculating the Zj, I need to write the elements of coefficient of these variables. So this is minus 1, this is 0 and 0. So if I calculate the Zj, I'll get this minus 1. This would be minus 3. X1 coefficient is 3. The coefficient of x1 is 3. So what I'll do, I'll use these coefficients and multiply them. So I'll have this 3 multiplied by 1, I'll get here 3. Then I'll have 3 into 3, which is 9, and plus 0 into something, it would remain same. And 3 into 0 is 0, plus 0 into 0 is 0, plus this is also 0. And for the next, I have this 3 into 1, which is 3, then 0 and 0, so it is 3. And for the last, I have this 0. Now I need to find out what is Cj minus Zj in this particular step. So 3 is that objective function's Cj value, 3 minus 3, it would be 0. Minus 1 minus 9 is minus 10, 0 minus 0 is 0, 0 minus 3 is minus 3, and then you got a 0. So ultimately what you have done an iteration, and doing that iteration, what you achieved all these elements of Cj minus Zj part as either 0 or negatives. That means your solution would now be an optimal solution. And how to mention that solution in the answer, that is to be taken care of. So in order to mention that particular solution, this would be your final answer. That means after performing the second phase, the final answer would be x1 as 2 and y value, or you can say x2 value, that would be 0. And S1 value will be 2 here, that hardly makes any difference, and S3 value is 4, that also do not make any difference to the objective function. But when I want to find out the objective function, which is Z max, that objective function would be the sum product of these two columns, the sum product of this CB values and the solution value. So 3 into 2 is 6 plus 0 plus 0. So Z max would be 6. So here I need to mention that the value of Z max is equal to 6. So this is the final answer, but one major thing that is required to be noted in this question is the placement of S1. So here you can see that S1 was entered in place of S2. That hardly makes any difference to the objective function. But the only thing is, only difference that it is making is the change in those coefficient values. If this coefficient values changes, the solution would automatically change. So you can see that whenever this S2 was replaced and S1 was entered, so these solution values also got changed. So ultimately this method told us that this is not an optimal solution. So in order to make it an optimal solution, you have to do the iteration and perform a next set of solutions. So this would be the particular case related to a two-phase method. So with this, we come to an end of the video in which we learnt about the two-phase method of the linear programming problems. And we learnt the case of first phase, in which we have substituted all the elements of the decision variables as 0. And we tried to convert that particular aspect into a simplex problem. And we got a final answer to the maximization type problem. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.